Statistical process control, controlling the variability in a production process by measuring the standard deviation of random samples, where the population standard deviation is known. We have 2-litre bottles of cola. Some have slightly more than 2 litres, some slightly less, so there's variability in the amount of cola, and we can measure the variability by taking random samples and measuring the standard deviation. So for process control, take regular samples, measure the sample standard deviation, plot the standard deviation on a control chart to see what happens over time. A fully worked example on this method. So the machine here is filling packets of crisps. The weights of the packets of crisps are normally distributed. The mean is 153 grams. This standard deviation is for the population, so it's known, it's 2.5 grams. Random samples of size 4 are taken at regular intervals. So we're going to calculate the upper and lower warning limits and action limits for the standard deviation. And then we can represent these on a control chart for the standard deviation. Now, table 12 in the AQA formula book tells you exactly what to do. For standard deviation charts, multiply the standard deviation, and we know this value, it's given, by the appropriate value of E. Our sample size is 4, and these are the E values, so our focus should be here. And then using these values and multiplying these E values with the population standard deviation, we can work out our limits. So for the warning limits, so the E value times the standard deviation, so these values are from here, and it's simple, we just multiply them with the population standard deviation. So our limits here go onto the control chart for standard deviation like this. Part B, state the action, if any, you would recommend if a sample gave the following weights. So here's the first sample. Remember, we're taking samples of size 4. So these values are not the values that you plot onto the control chart. We have to work out the sample standard deviation using our calculator, and then we plot that value onto the control chart. So our first sample, the data goes into the calculator. There are 4 values, only 3 are shown here, there's a 4th one. And then it's option 4 that we're looking for here. Yeah, option 4 is the one where we're using the sample, this sample, to try and estimate the population standard deviation. It's option 4. Whenever you take samples from a population, we use option 4. And then option 4 gives us this value, so S is equal to 0.881. We plot this onto the control chart. So here's our first value, first sample, and the value's plotted. It's within the warning limits, no action required. There's no target on the standard deviation chart. The ideal target would be 0. When we're looking at variability and control charts, if we get very low values down here, we may want to take another sample just to see whether the process has really improved. For example, what changes have we made that have led to very small variability, which is an ideal situation. Our second sample, and this one is above the upper warning limit, so we want to take another sample immediately, and if the standard deviation of the new sample is outside the upper warning limit, then we need to take action. We would stop the process and change something to make improvements. Our third sample, so there's indication here that the variability has been reduced, which is a good thing. So taking another sample would be with the view to maintaining this improvement. Our fourth sample, and the standard deviation, it's above the upper action limit. There's too much variation in the production process. We need to stop the process and take action immediately. And sample 5, it's within the warning limits, no action required. So it's possible that after sample 4 we stopped the production process, made some changes, and the next sample that was taken has shown that the changes have been successful.